For part 3, we're told that this curve here crosses through 0, 13 and ln 3, 13. So if I draw a line across at 13, I know that that happens here, where x equals 0. So I know that it's positive 13 here. Now we need to remember that this part of the graph here was the original positive e to the kx graph. So that was e to the kx minus a. And over this side, we'd reflected this graph in the x-axis. So that's become the negative version of the graph. So that's minus e to the kx plus a. That's a kx. And we also know that this point here is ln3. So I'm going to use this coordinate first, and I'm going to sub that in to this equation here, because that's what's happening at this point. So at 0, 13, we've got that 13 equals minus e to the k times 0 plus a. We hopefully know that e to the 0 is 1, so we've got minus 1 plus a equals 13, and if I add 1 on, that will tell me that a equals 14. The other thing I need to do is work out what k is, and I'm going to now that we know that a is 14, I'm going to focus on the coordinate ln3, 13. So I can now say again that 13 equals, and I'm going to use the positive curve now because we're on that part of the graph, e to the k ln3, take away 14. So to solve this for k, first thing I'm going to do is add 14 to both sides. That gives me 27 equals e to the k ln3. The next thing I need to do is remember a little log rule, and the log rule that I need to remember is that a ln b is the same as ln b to the a. I can bring this power, this coefficient up as a power of b. So I'm going to do that with k ln3. I'm going to turn that into e to the ln3 to the k. And then what I'm going to do is realise that I'm doing e to the power of ln of something. And these are inverses. These would, if I apply one function to the other, they will undo each other because they're inverses, like squaring and square rooting. So what happens then is I'm just left with 3 to the power of k. And hopefully we'll be able to work out what k is there by sight. 3 cubed is 27, so k equals 3. If you don't like what I've done here, then I'm just going to explain this in another way. If you're happy with what I did, you can move on to the next question because I've finished it. But if you don't like what I did after that step, then I'm just going to explain it in a slightly different way. The other way we can work out k from here then is to log both sides. If I log both sides, I'll get on the right hand side ln of e to the ln of 3 to the power of k. And what I can do is I can use my log rule to bring all of this down as a coefficient in front of the ln of e there. So I'll get ln of 3 to the power of k times by ln e. ln e is 1, so we can get rid of that to leave us with ln 27 equals ln of 3 to the k. And because I've got log of this equals log of this, that tells me that 27 equals 3 to the power of k. And hopefully you'll be able to spot there that that means k equals 3, because 3 cubed is 27. Again, there's another option. You could use a log rule again and take that k to the front, and then divide by ln3, so k is going to equal ln27 over ln3. And if you work that out on your calculator, you get that k equals 3. So both methods work. There's 3 methods there. Hopefully one of them makes sense to you.